नमस्कार. मी क्वालिटी इम्प्रूव्ह इन मॅथ एज्युकेशन या प्रोग्राममध्ये आपलं स्वागत करतो. किंवा एमी व्हिडिओ बेस्ड पीपीटी प्रेझेंटेशन या अंतर्गत माझा भाग आहे वास्तव संख्या. माझे नाव ज्ञानेश्वर आधार धनगर. माझा रजिस्ट्रेशन नंबर B082. माझ्या शाळेचं नाव साने गुरुजी नूतन माध्यमिक विद्यालय अमळनेर, जिल्हा जळगाव. मला या शिक्षकांनी मार्गदर्शन केलं असे प्राध्यापक IK राणा, IIT मुंबई, तसेच प्रोफेसर HJ धारापुरे, IIT मुंबई. मित्रांनो, आपण मानवी उत्क्रांतीचा इतिहास बघितला. त्या इतिहासामध्ये जसा अग्नीचा शोध, चक्राचा शोध, तसा संख्यांचा शोध हा एक महत्वाचा टप्पा आपण मानतो. माणूस उत्क्रांत झाला. जसं जसं संख्या पुढे शोध लागत गेला, नैसर्गिक संख्या ज्याला आपण मोज संख्या असं म्हणतो, त्याच्यातला पहिला टप्पा आपण या ठिकाणी बघणार आहोत. तो म्हणजे निरीक्षण करा आणि शोधा. त्याच्यासाठी मी तुमच्या पुढे एक ऍक्टिव्हिटी ठेवतो की स्क्रीनवर आता दिसतंय. पहिली ऍक्टिव्हिटी अशी आहे, बेरीज करा. 7 अधिक 8 त्याची बेरीज आपल्याला करता येईल. नंतर दुसरी ऍक्टिव्हिटी त्याच अंतर्गत वजाबाकी करा. नंतर तिसरी गुणाकार करा. 2 गुणिले 0 बरोबर 0. तसंच चौथी भागाकार करा. 5 भागिले 2. त्यानंतर या ठिकाणी एक व्हिडिओ तुम्हाला दाखवतो की ज्याच्यामध्ये आपल्याला एक पुढच्या संख्या ज्या प्रकार आहे तो प्रकार लक्षात येणार आहे.
G'day and welcome to the Tech Math channel. What we're going to be having a look at in this video is a way of working the square root out of numbers. These are going to be looking where we've got the square, perfect squares that are occurring less than 100, but how to work these out in just seconds. Okay, so I'll show you how to do this. Anyway, so first off, we'll give you an example. So how fast can you work out the square root of 576? I'll give you a couple of seconds. Okay, time's up. Now, did you get the answer of positive or minus 24? If you did, that's great. You got the right answer there. If not, I'm going to show you how to do these. Now, just by the way, before I go any further, the square root here, it's really important that you actually identify this as a positive or negative answer, because say negative 24 times negative 24 gives us the answer of 526. The same way 24 times 24 gives us the answer of 576. So just before I go on, just make a note of that. Having said that, I'm probably not going to worry about doing the positive and minus for the rest of these numbers here. I'm just going to put them down as numbers, and you can assume that there's a positive or minus there. So I'm going to show you how we do this, and it's going to involve knowing your squares all the way up to, I've done it up to 9 because I think you should probably know 10 squared. I think you should know these already anyway. I think probably most of you will. But you're going to see that I've got jotted down here the squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on and so forth. We're going to be using these a fair bit. You're also going to notice, first off, that I've actually put the units of these in a different colour. I'm just going to draw your attention to those actually right now when we first are working out our answer here. So the way that we do it is as follows. The way we work out the square root of 576 using this is as follows. Okay, so first thing we do is we have a look at this particular unit's answer, the number here, okay, this 6. And we're looking for a square root here that corresponds to this, or a square that corresponds to this. So 16 does, and 36 does. And the square root that goes alongside of those, we have 4 when we're talking about 16, and we have 6 when we're talking about 36. So our answer is going to finish in a 4 or a 6. And we're going to work out for sure which one this is in a little second. But first off, we have to work out now our our first digit. So I'm going to cross out these 2 digits. It's the next thing we do. And we just deal directly now with this 5. Okay. Now, we're going to have a look here, along here, in our square answers here, and we're looking for a number that occurs just below 5. So it's either going to be the number 5 itself or the one closest to 5, which is under. Okay, so you're going to go along here and you can see 1, 4. 4 is just under 5 and 9's too much, so we're going to be dealing with this 4. Now the square root of 4 is 2. 2's the first part of our answer. Okay, now we're almost there. Now we have to just work out whether or not we're dealing with, is it 24 or 26 is our answer. And the way we do this is as follows, is we get our 2 here and we just multiply it by the next number up, okay? And I mean the next number up from 2, which is 3. So 2 times 3 equals 6. Now, we have a look at this 6 and pretty much what we do is as follows. If this 5 here is less than this 6, we choose the lesser number, okay? If it was more, we choose the bigger number, okay? So 2 times 3 is 6, 5 is less than 6, so we choose the lesser number here. So our answer is 24. Okay, that was a bit of going through. I'll tell you what, we'll go through a couple more of these. You'll pick them up as we go along. And then what I'd recommend is you'll probably be able to start pausing it and giving it a go. Okay, so let's get into another one of these. So what about we do 1,849, and we're going to work out the square root of this. So first off, once again, what we do is we're looking at this 9 here. Okay, the 9, and the number that goes along with our 9 could either be a 3 or a 7. You can notice these complementary numbers add up to 10 too. It's kind of a handy little thing. The next thing I do is I cross out these 2 numbers. Okay, so our answer is going to finish in a 3 or a 7. Now I look at this 18. So 18, and I go down here, and I'm looking, and 16 just occurs below 18. 25 is too much, so the square root of 16 is 4. The first part of our answer is 4. Okay, 4 times 5, okay, 4 times 5 is 20. And now I compare this to 18 here. So 18, as you'll see, is less than 20, so we choose once again the lesser number. Okay, so our answer is 43. You get faster and faster and faster at these. Okay, keep practicing them. You will get used to doing them. Okay. Okay, what about one more of these? 3,364. Okay, pause it. Give it a go. Okay, so looking at the last number here, it could be either a 2 or an 8. Okay, so let's cross out these 2 digits here, and now what we do is we are looking for that first digit. Okay, so it's going to be a 5. Okay, you're probably working that out really, really quickly. Okay, because 5 5 is 25, 6 6 is 36. That's too much, isn't it? So let's go 5 times 6. 5 times 6 is 30. 33 is bigger than 30, so we're going to choose the bigger number. We have an 8. So our answer is 58. Okay. What about another one? What about a bit of a different one here? We'll do 2025. Now this is a nice and easy one, and you'll see why. Okay, pause it and give it a go. Okay, so 2025, you're going to see that it can only be a 5 at the end here because there's no other option. Okay, cross that out. And then we're looking for the number which is going to be occurring under here. Okay, so 4 squared is going to be 16. 5 squared is too much, so it's going to be a 4. But this is our answer because we don't need to differentiate between whether it's a 5 or that. It's just that 5, isn't it? So 45 times 45, that's our answer. Pretty cool, right? Okay, a couple more of these. Just I've got about 3 more of these. I'll put them out there. I recommend practicing them and see how you go. So 5,184. Okay, so our last number could either be a 2 or an 8. Okay, 7 squared is 49. So this is going to be a 7. Okay, 7 times 8 is 56, and 56 is 51's less than 56, so we're going to choose the 2. Okay, this is how I start doing these in my head. I'm going to start doing them more and more like this. I'm going to do the rest of them like that, I reckon. So what about 1,444? Okay, so the last number here could be a 2, or it could be an 8. Okay, so 14, 16 squares, 4 squares too much, 3 squares good. So it's going to be a 3. 3 fours are 12. 14's greater than 12, so we're going to choose the greater number, which is an 8. 38. Alright, lucky last one out of all of them is 8,281. Okay, so as you see here, 81, 81, I'm only going to look at the last number here. I know it's sort of tempting to go 81, hey, wait a second, that's 9. I'm only going to look at the last digit here. So 81, it could be a 1 or a 9. Okay, so what we'll do now is we'll cross that out. And 82, okay, so 82, once again, this is going to be a 9, okay. Well, it's not going to be a 9 because it's not necessarily a 9. So we've got 9, okay, so 9 times 10 is 90. 82 is less than 90, so we're going to choose the lesser value. We've got 91. Anyway, what did you think of that particular trick there? It's not a bad trick, okay? It does take a bit of getting used to, but once you get used to it, it's actually fairly handy, okay? And it's a great little way of working them out. You start to be able to work them out, as you see towards the end, much faster, okay? And yeah, you will make the odd mistake, but hey, everybody does this. Hey, now, in a future couple of videos, I am going to be looking at about how to work out how to calculate squares of any number, okay? The laborious, slow way of doing this, but it's not the slowest way ever. Just a nice little trick for doing these, and something you may or may not know how to do already. Anyway, thanks for watching. See you next time. Bye.
की वर्गमूळ. आता संख्यांची वर्गमूळ आपण काढतो, परंतु कशा पद्धतीने काढायचे ते आपण या व्हिडिओमध्ये बघणार. त्यानंतर पुढची ऍक्टिव्हिटी तुमच्यासाठी. मित्रांनो, या ठिकाणी मला सांगायला आनंद वाटेल की भारताला 1947 ला स्वातंत्र्य मिळालं, परंतु भारत स्वतंत्र झाला हे ऐतिहासिक महत्व झालं. मग आपल्या गणिती दृष्टिकोनातून जर त्या वर्षाला बघायचं झालं तर त्याच्यामध्ये खूप मनोरंजक अशा पद्धतीने आपण 1947 जे इंडिपेंडन्स इयर आपण म्हणतो त्याला आपण बघणार आहोत. आता या स्वातंत्र्य वर्षाचे अंक जर बघितले तर 1947 या पद्धतीने आपल्याला ते अंक सांगता येतील. ह्या अंकांचा कुठेही क्रम न बदलवता फक्त त्याच्यामध्ये बेरीज, वजाबाकी, गुणाकार, भागाकार, वर्गमूळ किंवा वर्ग अशा पद्धतीचे क्रिया करून आपल्याला काही संख्या मिळवता येतील का? जसं की तुम्हाला स्क्रीनवर दिसतंय की 1 + 9 वजा वर्गमुळात 4 वजा 7 अशा पद्धतीने आपल्याला 1 मिळवता येईल. अशाच पद्धतीने 1 गुणिले वजा वर्गमुळात 9 वजा वर्गमुळात 4 अधिक 7 अशा पद्धतीने आपल्याला 2 मिळवता येईल. परंतु आता 1 आणि 2 या ठिकाणी आपण मिळवून बघितले. पुढच्या संख्या मिळवता येतात का याच्यासाठी आपल्याला प्रयत्न करायचा आहे. मित्रांनो, निश्चितपणाने हा प्रयत्न जर आपण केला तर गणितामधल्या ज्या मूलभूत क्रिया आहेत, जसं आपण कंचे भागू बेव म्हणतो, ते तुम्हाला आल्याशिवाय राहणार नाहीत. म्हणून याचा सराव करणं आणि याच्या पुढच्या संख्या आपल्याला शोधणं गरजेचं आहे. दुसऱ्या टप्प्याकडे वळूया. डिफाईन अँड टू प्रूव्ह म्हणजेच व्याख्या आणि सिद्धता. आता या ठिकाणी परत तुम्हाला एक व्हिडिओ दाखवतो. या व्हिडिओमध्ये तुम्हाला दिसतायत एक बॉक्स आहे, त्याच्यामध्ये काही संख्या जात आहेत. आता इथे नैसर्गिक संख्या, पूर्ण संख्या, पूर्णांक संख्या, परिमेय संख्या आणि त्याचा पुढचा टप्पा अपरिमेय संख्या. जसं नैसर्गिक संख्या n ने दाखवतो, पूर्णांक संख्या w ने दाखवतो. जेव्हा 0 नैसर्गिक संख्यांमध्ये मिळवतो त्यावेळेस आपण त्यांना पूर्ण संख्या असं म्हणतो. त्याच्यानंतर पूर्णांक संख्या म्हणजे नैसर्गिक संख्या, त्याच्या विरुद्ध संख्या आणि 0 यांच्या मिळून जो संख्या संच तयार होतो त्याला पूर्णांक संख्या संच असं म्हणतो. त्याच्यानंतरचा जो टप्पा येतो त्या परिमेय संख्या, इंग्रजीमध्ये त्याला आपण रॅशनल नंबर म्हणतो आणि तो क्यू ने दाखवतो. हा क्यू फॉर कोशंट, द नंबर विच इज रिप्रेझेंटेड इन द फॉर्म ऑफ P/Q, आणि म्हणून आपण त्याला क्यू हा संख्या संच म्हणतो. आणि त्याच्या पुढे आता व्हिडिओमध्ये तुम्हाला जे अपरिमेय संख्या आहेत त्या कशा आहेत ते दिसणार.
Hello, I'm Professor von Schmohawk, and welcome to Why You. In our lectures so far, we have seen how numbers evolve from the primitive concept of natural counting numbers to whole numbers with the addition of the number 0, integers with the addition of negative numbers, and then rational numbers. Since rational numbers are closed under all four arithmetic operations, addition, subtraction, multiplication, and division, you might think that rational numbers finally represent a complete collection of numbers. We can add, subtract, multiply, and divide, and never have a problem representing the result. Yay! This is what the Greeks thought as well. That is, until they discovered an inconvenient truth: that there are certain types of quantities that cannot be represented by rational numbers. Nobody knows exactly who made this disturbing discovery. It may have been the great Greek mathematician Pythagoras, but legend has it was one of his students, who was subsequently killed for upsetting the apple cart with this discovery. Numbers were obviously a sensitive subject for the Pythagoreans. The proof of the existence of irrational numbers may have gone something like this. If rational numbers can represent any quantity, then they should be able to represent square roots. Now, the definition of rational numbers says that any rational number can be represented as the ratio of two integers. In other words, one integer which we will call p divided by another which we will call q. P over q is obviously a fraction, and like any fraction, we can write it in its simplest form so that the integers p and q have no common factors. We also know that since the square root of 2 is not an integer, the denominator q is some number other than 1. Now, since the square root of 2 and the quantity p over q are equal, then we can square them both and they will still be equal. The square root of 2 squared is 2, and the quantity p over q squared is p over q times p over q, or p times p over q times q. For this fraction to be equal to 2, we must somehow be able to reduce it to 2 over 1. But we already saw that q was not 1. So the only other way this fraction could be equal to 2 over 1 is to cancel out common factors in the numerator and the denominator. But we also said that p and q have no common factors. Therefore, there are no factors in the numerator that are the same as any factor in the denominator. So we can't cancel any factors, and there is no way that this fraction can be equal to 2. Therefore, this is an impossible situation. Our original assumption that the square root of 2 can be represented by the ratio of two integers must be wrong. The square root of 2 must be some value which is not a rational number. A number which is not rational is called an irrational number. This same argument can work for other square roots. For example, we can start with the square root of 3 and try and represent it as the ratio of two integers with no common factors. Squaring both sides, we get 3 equal to p times p over q times q, and since p and q have no common factors, this fraction can't be reduced to the integer 3. Therefore, the square root of 3 is irrational. This also works for roots other than square roots. For example, we can set the cube root of 2 equal to the same ratio with no common factors. Then cubing both sides, we get 2 equal to p times p times p over q times q times q, and since p and q have no common factors, the fraction can't be reduced to an integer, and so the cube root of 2 is also irrational. We saw in the chapter on converting fractions to decimal numbers that the rational numbers can be represented as decimal numbers which either repeat or terminate. A terminating decimal number has a finite number of digits after the decimal point, while a repeating decimal number ends with an infinitely repeating series of digits. The repeating sequence of digits can be as long as we like, but the number of digits which repeat is always finite. In other words, all repeating decimal numbers contain some finite number of digits which repeat infinitely many times. However, when we try and represent an irrational number as a decimal number, we find that the number will always contain an infinite sequence of non-repeating digits. No matter how many digits we write after the decimal point, the digits will never repeat. Therefore, we can never perfectly represent an irrational number either as a decimal number or as a fraction. With the invention of calculus, mathematicians were able to prove that numbers like pi and e are also irrational. In fact, there are an infinite number of irrational numbers. In the next lecture, we will see how mathematicians eventually combine the irrational numbers with the rational numbers to form the real numbers.
आणि आता शेवटच्या टप्प्याकडे जाऊया, डिफाइन अँड टू प्रूव्ह. म्हणजे उपयोजन, व्याख्या आणि सिद्धता. आता व्याख्या आणि सिद्धतेमध्ये जर जायचं झालं तर संख्यारेषा आपल्या सगळ्यांना ज्ञात आहे. आपल्याला या ठिकाणी संख्यारेषा दिसते. त्या संख्यारेषेवर आरंभबिंदूच्या उजव्या बाजूला सर्व नैसर्गिक संख्या आणि त्याच्या डाव्या बाजूला त्याच्या सर्व विरुद्ध संख्या असतात. म्हणजे ऋण संख्या असं आपल्याला म्हणता येईल. आता या संख्यांच्या संदर्भामध्ये आपल्याला संख्यारेषेवर असे अनंत बिंदू असतात. प्रत्येक बिंदू एक संख्या दाखवत असतो. संख्यारेषेवर भलेही आपण मर्यादित संख्या दाखवत असू, परंतु संख्या एवढ्याच असतात का? तर त्याचं उत्तर नाही असं येईल. आणि मग एवढ्या नसतात तर मग अजून संख्या असतात. मग ह्या संख्या आपल्याला कशा दाखवता येतात? तर इथे आपण जर बघितलं तर 1 ते 2 या दरम्यान अशा अनंत बिंदू आहेत आणि प्रत्येक बिंदू एका संख्येशी निगडित आहे. मग हे अनंत बिंदू आपल्याला जर दाखवण्याचा प्रयत्न केला तर अनंत संख्या सुद्धा येतील आणि अशा पद्धतीने आपल्याला त्या ठिकाणी परिमेय संख्या दाखवता येतील, अपरिमेय संख्या दाखवता येतील. म्हणजेच थोडक्यात आपल्याला असं सांगता येईल की या ठिकाणी वास्तव संख्यांच्या मध्ये आपल्याला नैसर्गिक संख्या सांगता येतील, पूर्ण संख्या सांगता येतील, पूर्णांक संख्या सांगता येतील आणि परिमेय संख्या सांगता येतील. म्हणजे हे एकमेकांचे आता संचच्या भाषेत सांगायचं झालं तर नैसर्गिक संख्या हे पूर्ण संख्यांचा उपसंच होईल, पूर्ण संख्या या पूर्णांक संख्यांचा उपसंच होईल आणि पूर्णांक संख्या या परिमेय संख्याचा उपसंच होईल. मात्र ज्यावेळेस आपण रिअल नंबर दाखवतो की जे संख्या रॅशनल नंबर्सचे उपसंच झालेले आहेत ते आणि इरॅशनल हे स्वतंत्र संच तयार होतील. आणि हे दोन्ही स्वतंत्र संच म्हणून आपण या ठिकाणी म्हणतो की ज्या संख्या परिमेय नाहीत अशा अपरिमेय संख्या, जे क्यू डॅशने आपण दाखवतो, आणि परिमेय संख्या आणि अपरिमेय संख्या यांच्या मिळून जो संच तयार होतो त्यालाच आपण वास्तव संख्या असं म्हणणार आहोत. आता ह्या ज्या वास्तव संख्या आहेत या वास्तव संख्या द नंबर विच आर इन एक्झिस्ट इज कॉल्ड रिअल नंबर्स असं आपल्याला थोडक्यात त्याचं सांगता येईल. आणि अशा या वास्तव संख्या आपण इथे शिकलो. आता शेवटचा टप्पा आपला असा असणार आहे उपयोजन आणि मूल्यमापन. उपयोजन आणि मूल्यमापनामध्ये आपल्याला या ठिकाणी काही परिमेय संख्या दिलेल्या आहेत ज्यांच्या दशांश अपूर्णांकामध्ये रूपांतर आपल्याला करायचं आहे. ते उदाहरण आपल्याला सोडवण्याचा प्रयत्न करायचा आहे. तसंच दुसरं उदाहरण या ठिकाणी दिलंय आपण, वर्गमूळ काढा. 7 + 2 वर्गमुळात 10 याचं वर्गमूळ काढण्याचा प्रयत्न करायचा आहे. तसंच आपल्याला छेदाचे परिमेयीकरण करा, म्हणजे छेद परिमेय संख्या आली पाहिजे याच्यासाठी कुठल्या गणिती क्रिया करून हे उदाहरण सोडवता येतं का, जमतं का, आपण बघूया. मित्रांनो, या ठिकाणी मी जे तुम्हाला सांगितलं ते माझ्या ज्ञानाप्रमाणे सांगण्याचा प्रयत्न केला. आपण ते निश्चितपणानं गोळ करून घ्याल याची मला खात्री आहे.